Hello everyone, how's everybody doing? I hope you're all doing fine, a little better than me. Woke up with a little stiffness in my back, had to be careful throughout the morning, but later on as I moved the skeleton, did a little bit of exercise, it got better. So yeah, obviously it's old age and lack of exercise. I got to do a little more of that. Anyways, let's get right into it. I'm going to be looking at some of the fan mail, okay, blowing around there. Okay, so let's start with the first one. And here we have, this fella says, Bill, I've been a fan of yours since the days of Einstein's idiots and relativity blues. You are at your best when you expose the idiocy of mainstream mathematical physics. Okay, thank you. But please, subjects like economics, anthropology, and sociology, you demolish your credibility and sound like a senile old coot desperately babbling for attention. Skip the dope theory, meaning rope theory, right? Skip economics, skip anthropology, skip sociology. Just focus on mocking the mathematical physicists. Well, I'm a little worried that this guy is a follower of mine. You know, it's like it's a little creepy, you know, please don't follow me. Yeah, no, if he's a follower, I don't know what he's been following, because obviously, you know, he doesn't understand half of what's going on then. Because the point of this channel, right, is to expose, yeah, the establishment. You criticize them, but science is not, and physics is not, criticism. Physics and science are explanations, okay? So it's not sufficient that you criticize someone's theory. It's what you propose in the alternative. You give people a choice. You say, look, this is black and this is white. You know, this is on, this is off. Okay, so you compare them, you contrast them. That's the point. So I don't just bash the establishment. Hopefully I'm giving you something in exchange, something that makes you think and see the world, the universe, in a different light. That's the point. And incidentally, you know, I've said this in the past, way in the past, and some of the new people may not be aware, but I answer questions only in Patreon. I don't have time to patrol all my sites. I have several sites. And so I answer in Patreon. And you do not have to donate any money or anything like that. It's just that I chose that site, and people can bring up questions in my Patreon site. And you can find the reference in the description there at the bottom, the last one I think it is. Anyways, let's get on with it. Here's another comment. I don't give a dime. I guess he meant the damn for your definitions. I have free will, so I redefine them all. Okay, good. And if you have a problem with that, go eat your simulation. Yeah, he defines them all, but he defined none. I don't see any. And you won't find definitions from any of these people. No one has learned how to define words scientifically in a way that they can use them consistently. They simply take the words of ordinary speech from the dictionary, from the Wikipedia, from wherever they find it, and they say, well, this is what this word means. But they never analyzed. They just copied and pasted. That's it. That's all they did. They never analyzed the word. And there are critical words in science, that you, especially in physics, that you must absolutely define, or you cannot do physics. And here's a set of them. I usually put them up here, okay? And these form the foundations of physics. You can't do physics without them. First of all, we start with the golden principle. Physics requires an object, and you can't do physics without an object. There's nothing in the universe. There's not one thing that's happening, nothing that you're observing, nothing that you can talk about. So you better have objects in the universe. Okay, and no one ever figured that out in so-called the history of physics. Okay, and what is something? That which has shape. Okay, there's some synonyms there. We call them object usually, but something is a synonym. Nothing is its opposite. It's an antonym. And if something is that which has shapes, nothing is that which doesn't. Period. We're done. We can use these two words consistently now. Distance, separation between objects, location, set of distances, and from there on you can define other words that are founded upon these four words. And that includes exist, motion, and the word concept. And yeah, a lot of these people, they don't want to define these words. And the reason is very clear. They don't know how to define these words. And that's what a religious individual fears the most, because suddenly he's cornered from a logical standpoint of view. You know, if you define your terms, say, look, this is what the word means, and I'm going to use them now, and he doesn't like that rigorousness in the language. He would like to be able to escape through some loopholes, you know, go on a tangent or whatever. No, and that's the problem. That's exactly the problem. The problem is people get off on tangents, go, you know, on the side of the road, so to speak. They take these whirlwinds through who knows what paths through the jungle. Why? Because they do not define their terms. If you define your terms, then it's very clear. Now, it doesn't mean you have to agree with these terms, okay, or with these definitions. You better agree to the terms, because if you're going to use them, then I'm going to stop you and say, look, define this term because I need it. I need to understand what's going through your mind. I need to understand what you think of this word, what it means to you. And you can't just improvise at the last moment and say, well, let me look it up in the dictionary. That means you had no clue. So I defined them. I've got them there. You don't like them? No problem. But you better come up with a good alternative that you can defend inside the ring. Okay? So put on your boxing gloves and be able to defend it. Okay, so yeah, we do work off of definitions, and no, this is not just petty semantics, as many people say. You need to establish the language of physics like you would need to establish the language of medicine, of the legal profession, the lawyers. Yeah, there are key words in every profession, in every discipline, and you need to define those terms in order to communicate within your discipline, within your field. Okay. And here's just a contrast between object and concept, which a lot of people have problems with it. If you go into the dictionary, you can put every word in there under these two categories. Either they're objects or they're concepts. There is no third category. Okay? And objects we point to and name. Concepts we define. We do not define objects, and we do not point to concepts. And here are some examples. You have the word object, you have the word rock under objects, tree, dog, circle, leprechaun. Leprechaun, some people say that's a concept. No, it's an object. I can draw a leprechaun for you, okay? Angel, angel's an object, okay? I don't know if you've seen them, but there's lots of pictures of angels. They have wings, they have a little ring or plate on top of their head. If you haven't seen an angel, well, then you don't know what an angel is. An angel is a physical object. It's got shape. Okay? Water is an object. People say, oh, that strikes me in the ear. Again, because they're using the notions of ordinary speech. They're not using scientific language. What is it under scientific language? That which has shape. Is this a question, what is the shape of water? No. It's a question of, does water have shape? Okay? And the answer is either yes or no. And anything made out of atoms had better have shape. That includes air and Mr. Zeus, our famous god that made us, I guess, the Greeks and all of us. Concepts are on the right-hand side. A lot of people have problems with this as well. You know, they might accept that energy is a concept. A lot of people don't. They don't even understand what energy is. There's no definition of this word anyways, but energy is a concept. And if you can put a number to it, or it represents a number, it had better be a concept. Okay? Information, space-time, and I want to focus on that word information because I'll be talking about that today. So information is a concept. What did I say up there? We don't point to concept. You can't point to concept. You can't draw a concept. But we're going to find out that some people think differently. Okay? Field, you know, magnetic field, electric field, gravitational field, concept. Plasma is a concept. What do you mean plasma? Plasma, these electrons that are, yeah, they're vibrating. Plasma is electrons in motion. A kangaroo that is jumping is not an object. It's a concept. The object is the kangaroo. If it's jumping, you're looking at a movie, you're looking at a film strip, you're looking at several frames. So you cannot say that a jumping kangaroo is an object. All objects have to be in a single photograph, static. They have to be the only object in the universe. There's no motion there, and the backdrop is nothing. In other words, space, vacuum. That's how we present objects in physics. You can't do that with plasma because plasma is ionized atoms. Ionized meaning there's some motion going on. That's why plasma is not a physical object, okay? But they don't understand that. Same with electricity, by the way, further down. Hologram. Hologram is not an object. It's not a standalone object. A bunch of lights that are projected onto a region. That's all, a hologram is. So hologram is not a I can't have a hologram in the middle of space being the only object in the universe. No, something gave it light, and that's how you build it. So it's like, a mirage or whatever, okay? Charge, same thing. So those are the differences, those are examples, right, of the differences between objects and concepts. And not everybody's in tune to these things, okay? And that's where the problem comes in, because they treat concepts as objects, and they treat objects, such as angels, they think, oh, that's a concept. Or they tell me that my rope is a concept. Or a guy the other day said the electron shell is a concept. No, an electron shell, a shell is an object. You take a shell of, like an eggshell, that's an object. Okay, I can see it, I can draw it, I can touch it, and not because of that, but because it has shape. Okay. Okay. One fellow brought this question up. I guess he's from India because or Pakistan or something. He said the cricket ball, there is empty space in it. Okay, you got a ball and you got empty space inside the cricket ball. Okay, which has circular shape, globular, spherical. Okay, can we call it an object? Okay, my definition of object is that which has always shape, criteria, or boundary condition. Okay, let's see where this goes. So according to my definition, empty space present in body is not object, because always after breaking cricket ball, it has no shape. And hence, it not follow boundary condition always, so it's not object. I think the word, the word always is missing in your definition. Okay, what's the problem here? He's saying something like this. Let's see if we can illustrate it, okay? Here we have a cricket ball. Okay, we have a cricket ball, and he's saying inside it has space, some vacuum or whatever it's got in there. Okay, air. Okay, we'll call it empty space. Let's say there's no matter whatsoever. Okay, so it's going to look like this. Okay, now we have space inside the ball. We're looking at it. Let's assume it's 3D. You can also assume 2D. I guess it doesn't matter. Okay, that's what we're staring at. Now let's get rid of the ball. Okay, let's the enclosure. Okay, so now we have space, just pure, unadulterated space. Okay, and the question is, what's the white stuff? That's the question, because we have space and it's surrounded by some white stuff that gives it shape or provides contrast. And so you have to identify the white stuff. And the other problem with what this fellow is saying is that he's saying that, it changes shape. Once you break the ball, the space in there, right, kind of oozes out or distorts itself. And I always give the analogy, and I try to get this through to people, and that's the best analogy that maybe you can use with other people. And that's, you have an astronaut. He's got a balloon full of air. You can put whatever you want in there. And let's color code it just to make sure that we can deal with it through the sense of sight. Okay, so we color code the air or whatever gas you put inside that balloon. You can't see it here, but now you put it in there and it's color coded. It's got some coloring. The astronaut takes it out into outer space, goes out, does his spacewalk, pinches the balloon, right? Pops it, and now this blob comes out, and it's color coded. So he can take a picture of that. Click. And it's a blob that's expanding in some irregular way. Okay? And so he's saying essentially, well, it changes its shape, so it's got to be always using time, right? And you can't use time because you got to define time after you define the word object. He doesn't realize that. But we have a problem anyways, because if I can take a picture of that blob, I just take one picture, one snapshot. I don't need the whole movie. I just need one snapshot. And whatever thing is in there, it's got an irregular shape. But the question is, does that blob have shape? It either has shape or not. It's a yes or no type of question. It's not a question of degrees of what is the shape of. No. The question with energy is not what is the shape of energy. No, the question is, does energy have shape? It's a yes or no question. Does field have shape? Does mass have shape? Does time have shape? You can't talk to me about warp time, that you warp time, until you first draw and show me that time has shape. What does time look like? And so you can't say, well, I don't know the exact shape of time. No, it's not a question of what is the shape of time. It's a question, does time have shape? It's a yes or no type of question. And time is a concept. No concept has shape. And this is another issue, that people don't always get, especially religious people. They'll never get that. Okay? So the issue is he's got to provide a backdrop to space to talk about space, and he can't talk about changing shape, which is what a lot of these people talk about. Changing is a verb, and we're not talking about object is a static image. It's a static concept. So you can't talk about the changing shape, dealing something with objects. The word object has to have a static criterion first, and it cannot include motion or time. And he says use the word always. No, that's time. Okay, you can't use the word always to define an object. Okay, I think it's the same fellow. He goes on, he's got another issue. He said, you said that the electromagnetic thread cannot break, but this does not explain break criteria of stone. He's going to use this as an example, okay? He says, because stone involves lots of ropes, okay? And each atom are connected, so when stone breaks, right? When the stone breaks, that means the rope connecting should break and does not follow your hypothesis. Okay, we got a little problem here, and I'm not talking about the language because we can understand them. I can still understand them and still try to address his issue. Let's see if I can go slowly here. Here's the rock, okay? Let's put a rock first, okay? Here's a rock, okay? And so we're saying that the rock is connected by a bunch of atoms, right? That it's made out of atoms. So let's look at the rock inside. Here, we'll put it up there. Okay, let's go deep into the rock, and we find that it's made out of atoms, and those atoms are connected by the electromagnetic ropes. Okay, that's the proposal. Okay, so what we did is we go deep into the rock, and we're seeing all these atoms that are interconnected. We're just looking at a very small region. Okay, so when you go into the rock, that's what you should find. You should find eventually atoms which are interconnected by ropes. That's the hypothesis. Okay, so the question now is, what happens when you break the rock? Okay, and here, let me show you in a second here. We're going to break the rock in half. Okay, and the question is whether the ropes are broken in half. Okay, do the ropes break in half as well? And the answer is that no, the atoms separate, but the ropes, you can't cut the rope. The rope just stretches, the rope doesn't stretch. What happens is the atoms just get farther and farther from another atom, and in that case the rope is longer, and the atoms can come closer to each other, in which case the rope is now shorter. So all we can do is just get atoms farther and farther away from each other, or closer and closer to each other. You're not breaking the ropes. What we see are the atoms. What we deal with in the real world today are atoms. We're not going to be able to cut the rope or do anything with a rope, and that's something these people don't understand, because they treat it like a physical object, as what they think is a physical object. What is a physical object according to them? See and touch. They think they can see, that an object is that which you can see or that you can touch. That's the problem. So they bring this see-touch criteria to deal with a rope. And the only, I always like to show my little rope here, the only property that the rope has, the reason I chose the word rope, is the shape. Okay, so when I use this as an analogy for the electromagnetic rope, to say, well, it's got this shape, it's got DNA-like shape. That's it. Okay, it doesn't go further than that. Can we touch the rope? Not the electromagnetic rope. You can touch this rope, but you can't touch the electromagnetic rope. Your hand will go right through it. Okay, because it doesn't have the property of touch, and it doesn't have the property of see, because you need the rope to see. Okay, so you can't put a rope coming into another rope to see the rope. Okay, I don't know if you get that. If I use the rope, if my atom is connected to the screen right now, and that torsion through the rope is what causes light for me to see that pixel on the screen, right? Or that atom on the screen, or whatever, a group of atoms, right? I cannot use that same mechanism of the rope twirling to see between two atoms, a rope that connects them. You cannot see the rope because it's very thin. Some people say maybe it's in the Planck range, you know, what is it? The fine constant. What is it? I can't remember the term now. The fine constant. Can't remember the other word. So it's very thin. You can't see an atom. You can't see a hydrogen atom. And you have gazillions of ropes from every atom in the universe converging upon our atom and constructing the atom, which is way bigger than the rope. So you're talking about something unimaginably thin and small. And so to say, well, can I touch the rope? Why can't I touch the rope? Why can't I see the rope? Well, you got to look at what you're asking. You can't see an atom. Why would you see the rope? Okay, so this is where people have problems, and the problem starts with the definition of what an object is. People think that an object is that which you can see and touch, and you say, well, a rope is an object, yeah. So why can't I see and touch it? Because that's not what the definition of an object is. Definition of an object is that which has shape, and this has the shape, the electromagnetic rope has the shape of a rope. Okay? Now, we have a little difference because this rope has ends. Okay, and here we would put the atoms at the end, right? But the rope constructs the atoms. Okay, so you're using the threads that twine and construct the rope. Those are the ones that are going to construct the atoms. So the rope doesn't have an end. You can artificially say, well, that ends where the atom begins. Yeah, but the rope is not completely an object in that sense. It's not contoured completely all around, not the electromagnetic rope. So here we have a difference with the regular rope that you buy at the hardware store. Okay, here this one's finite. The other one is, the word is not infinite, it just means it continues and turns into an atom, then it continues as a rope, then it continues as an atom, and so on down the line. And what we have is a single thread in the entire universe. Now that is an object, a single thread. You can say that's an object because it's completely enclosed. And then the issue there is whether it exists. In order for it to exist, it's got to have location with respect to something else, and there is no something else, not even God. So that's a question of definition. That's a long story. I'm not going to cover that here today. But just keep in mind that's an issue, whether the thread exists. And for that, we got to sit down and drink a couple beers and really discuss in detail what we mean by exist in the context of the thread, the single thread. Okay, let's move on here. Another person asked, have you spoken about LIGO? Okay, and what do you think about their findings? LIGO got a little prize there for saying that they found gravity waves. Okay, and they had all these centers there, and they measured and did all their little thing, and they said, hey, pull out the champagne bottles, we proved gravity waves. Okay, and they said Einstein predicted them. Well, the first thing we got to say is no, Einstein did not predict them. Here is an expert that studies Einstein a great deal. Her name is Galina Weinstein. She works off, I think, Jerusalem University. She studies she studied all of Einstein's paper, and this is one of the things she says about Einstein. Summary here, I try to condense her abstract, okay? In his gravitational waves paper, Einstein concluded that gravitational fields propagate at the speed of light. Einstein made a mathematical error. This error caused him to obtain 3 different types of waves compatible with his approximate field equations: longitudinal waves, transverse waves, and a new type of wave. Let's see what this type of wave is. Einstein added an addendum in which he suggested that in a system minus g equal 1, only waves of the 3rd type occur, and these waves transport energy. He became obsessed with his system minus g equals 1. Einstein's colleagues demonstrated to him that in the coordinate system minus g equals 1, the gravitational wave of a mass point carried no energy. But Einstein tried to persuade them that he had actually not made a mistake in his gravitational waves paper. Einstein, however, eventually accepted his colleagues' results and dropped the restrictive condition minus g equals 1. This finding led him to discover plane transverse gravitational waves. Okay, well, the story continues in that by 1936, Einstein got rid of the gravitational waves altogether. But see, his followers today say, oh, Einstein, we've proven Einstein's theory or paper, his proposal. No, you didn't, because Einstein denounced his own proposal, okay? And the other thing is that the only thing Einstein is saying is that he's got gravitational waves that carry energy. And in other words, he's still talking about transverse waves. There is no 3rd wave other than, for the first time, the torsion wave, a 3D wave, which nobody ever thought about. Okay, everybody's thinking about longitudinal 1-dimensional longitudinal waves, 2-dimensional transverse waves, which is what Einstein was saying as far as gravitational waves, which is what LIGO supposedly discovered. And then there's the torsion wave. I don't call it that. I don't like to use that word, but it's just so that you can relate to the fact that it's a 3D sort of wave. It's a torsion, okay? And now we can see why light is so fast, because do it at home, you know, like I say, put a rope between 2 posts, okay? Put 2 clothespins, move one clothespin, the other one moves instantaneously. In fact, I tried to film it. I did film it, in fact, and you can see it's instantaneous. And of course, short distance, but it just shows you how fast a torsion wave is. You can also visualize it. You don't even need to do an experiment. Torsion wave is the fastest thing imaginable. Nothing in the universe travels as fast as a torsion wave. Okay, and that's why light is so fast, because it is a torsion wave. Or you can simulate it with that. If you got a better idea, let me know, okay? So we'll see if it competes against my torsion wave. Okay, so no, LIGO says they discovered gravitational waves, and one of the problems with that is that it says that gravitational waves travel at the speed of light. That means 300,000 kilometers per second. That means that, again, if we go to what we said a couple weeks ago about Brian Greene, that if the sun happens to disappear, according to the mathematical establishment, it would take 8 minutes for us to receive the signal. Well, maybe that could be right for light, not for gravity. Gravity would fly out immediately, instantly, as they say. Why? Because it's here's the simulation, okay? Okay, here's the Earth, and assuming my hand is the sun, okay? So the sun twirls let me make it smaller. Sun twirls the Earth around, you know, like that. That's why the Earth doesn't leave the solar system. What happens if we cut the string, I'm going to let it go? Well, it didn't take 8 minutes. That's, I can assure you. The Earth would fly away instantaneously, because every atom in the Earth is connected to every atom that comprises the sun. Okay, that's the proposal. Whether you believe it or not, the important thing is that you understand what the proposal is. You reach your own conclusions. Okay, let me go with this one. One fellow says, Bill, you should see this madness. He points to a site, okay, to a video in YouTube. So I went there and find out, okay, what is this all about? And so he points to JFG, JF Gariepi, my good friend from Canada, and he has this idea that mass, energy, and information are connected. But he says something that just blew my mind, and that's that information, listen to this, information has mass. He says that information has mass. That was quite scary, but it didn't stop there. He said he can draw information. In fact, someone asked him, can you draw information, like illustrate it? He said, oh yeah, of course, I can draw information. I said, my God, what is he going to draw? And he drew this. This is what he drew, my good friend JFG, okay? And he talks about bits, and he says a bit is information, okay? So we have all this information, right? And he can draw it with zeros and ones and whatever. So he's referring to bits. He calls that information. He says he can draw information. What's my answer? Well, here's my answer, okay? I guess most of you know it. Here's love. I drew love on the left-hand side. Is that love? I drew a point in the center. Is that a point? Or is that a dot? And then we have JF's information. Well, he didn't draw information. What he drew was something that represents pictorially what he calls information. He's talking about bits of information. And what is a bit? Usually, I mean, it's not true, but think of it as a transistor, okay? Think of a bit as one transistor, and that transistor turns on or off. It's 0 or 1. It's a binary system. I worked in the semiconductor industry for many years, as some of you know. And let me give you a little rundown what a bit is, okay? How a computer more or less works, just in general terms. I'll give you a whole class here, but just so we put it in the proper context, okay? Oh no, first I wanted to say that this is, who is it? This is Neil Tyson, and the guy who he interviews, who used to be the guy who gave him, I guess, or got him into Columbia University, and also eventually gave him his degree. And this is what he says about bits, you know, talking about weight of bits, weight of information. It says, IBM estimated that we generate about 2.5 quintillion bytes. Byte is 8 bits, I'm going to go over that in a second, of information per day. So you can imagine all the weight, all the mass we're creating according to JFG, because we're creating all these bits and bytes, okay? A 1 followed by 18 zeros, that's per day, okay? If you print it out, it would fill a bookcase that stretched around the equator and was half a kilometer high, okay? So according to JFG, where he got his information, he says that we're creating, that information has weight, has mass, right? And this guy says we're creating a bunch of mass every day. Does this make any sense anymore? I mean, what these people are saying? Okay, here's a little pictorial of what bits are, okay? If you have a bit that has 2 values, zeros and 1, a 2-bit has 0, 0, 1, 0, 1, 1, 0, and 1, 1, and a 4-bit has 16 values, 16 combinations. 8-bit has 256 combinations, okay? So this gives you an idea how it's done, okay? So why they use the binary system, because you can turn a transistor on or off. And it's just not a transistor, it's more complex than that, but just so that you understand the basics. If a transistor is turned on because it's got 1 volt in it and another one has 0 volts through it, well, you can create this 0-1 combination, right? And if you have 256 of them, well, you can create words and letters and all kinds of things. And here I'll give you a little rundown of what a byte is, and that'll put it also in perspective for those of you who are not familiar with this. Okay, here you have the letter A, okay, and you see it's 0, 1, bunch of zeros and then another 1, and the ones are the ones that are turned on. Okay, so 1 byte is 8 bits, but it's got to be coded like that, and there's one set of zeros and ones for each letter, for each word, okay, for each symbol, and that's how the computer reads this thing. Okay, so here you see letter A is 0, 1, what is it, 6 zeros and a 1, and the ones are the ones that are turned on. Okay, and that whole thing is known as a byte. Okay, so that's essentially how computers work. Okay, that's how machine language, how the machine reads this language. Okay, and yeah, if you want to see what a chip looks like, well, let's go first to show you what a chip looks like. Okay, why it's so complex. Well, you can see this array of transistors. It's mind blowing. It just blows your mind completely away. Okay, it's very complex, and you have all these zeros and ones going on in there, and it's done all electrically or electronically. Okay, and then here's a chip. Okay, you go into the chip. Okay, you see how it's constructed. It's a city. The only thing it's lacking are the people. It's a garage space, anything you want. But it's very complex. Okay, so yeah, when you look at a chip, this is what I fabricated for many years. Goes into what is called a wafer, and you can see how small it is with respect to the wafer. When you go in there with a SEM or a scanning atomic force microscope, you can see the little details, and it's a little city. All these connections, and electricity goes through there, and it turns some into ones, others into zeros, and with this combination they create words and what have you. So yeah, it's a very interesting field. Very few people are experts in this stuff in the world. In other words, the day that these people die, nobody knows how to make a chip anymore. But it's a very complex thing, and again, it functions on the basis of 0 and 1s, but we call those bits. Let's assume we're just going to do it with transistors just for simplicity's sake. So you have a 0 and a 1. A transistor can turn into a 1 or a 0. When it lights up, we'll call it a 1. When it turns off, we'll call it a 0, right? And with these zeros and ones, you can create a byte, 8 of them, right? And a byte is a letter, a word. You can call it a word, okay? And so the issue here is, what does that have to do with the weight or the mass of information? I mean, these people are confusing not apples and oranges, they're confusing apples and energy here. You know, one thing has nothing to do with another. It's just using concepts to explain the unexplainable. You know, you cannot say that that you can draw information that information has mass. I call that an idiotic statement. I'm sorry. Okay. No. Yeah, the chip has a transistor. That's you can touch that. You know, that's real. That's an object. Okay. If you can isolate one transistor inside a wafer or inside a chip, you can do that. Yeah. But to say that information out there, you know, someone sings and that's information. It's going through the air, and they say, "Oh, see, it's got weight, it's got mass." That's idiotic. Okay, so what can I say? Okay, last comment before we get into good old Tyson here. One fellow says, and again, you have all these people who have the flat earthers who abandoned me in my Spanish channel because they say, "Oh, we were following you." Well, don't follow me. It's so creepy, you know. All you crazy guys following me. You know, you're giving rational science a bad name. Don't follow me. I like it when people, you know, lose subscribers. When I lose subscribers, I'm really happy because I'm saying another one bites the dust. Okay, this guy made perfect sense, meaning me, right? Until he said, "Not even poor old God can do that." Okay, I would like to know what his scientific explanation would be for his personal existence upon this thing that is so-called life. I can agree that those so-called physicists you mentioned are really nothing but ignorant wannabe scientific experts. Let's not be illiterate and ignorant human beings that are so quick to ignore the Bible. Oh, but quick to pick up a textbook that has no real logical explanation of existence, but a bunch of theories behind it. Thinking we know about anything is already a foolish claim. We have no knowledge of how things really work. We can only assume. May God bless you, sir. Well, no, I don't want to be blessed by God because then the fellow downstairs, you know, he won't accept me there. And I want to go there because they say all the beautiful girls go there, you know. So I'd rather go south, not north, okay? That's my personal preference. Okay, but no, in science, what we do, we explain, and so we have no use for knowledge. Science is not about knowing. Science is about explaining a mechanism objectively, in terms of physics, right? Is explaining a mechanism objectively so that the other person understands. That's the end of science. What continues then is religion, belief, opinion. Whether you like something or not, whether you adopt it as your personal theory, as your personal savior, right, so to speak, right? And so, yeah, so these people don't understand just about anything. And the issue there is the word exists, and this troubles them because they never defined the word exist. So they want to rant about existence without having defined it. So what we do in science, we define the word exist so we can use it consistently. And here it is. So he wants to know what existence means to me, or what is my personal existence. Well, here it is. Scientifically, if it has physical presence, if it's an object that has location, that's what we call exist. So if God wants to exist, God had better be an object. First of all, if he's not an object, he doesn't qualify for existence. And then he's got to have location. There's got to be a distance between his finger and my finger. And as long as there's distance, then he exists. Otherwise, he doesn't. And yeah, the problem here is that under the rope model, and that's for everybody to ponder. What we have is a single closed loop thread in the universe. This is all we have according to the rope model. Okay, that's all that is there. Okay, and then again, the word exist is very touchy when you're talking about the thread, and that's got to be resolved, but in a little more detail than what I'm going to talk about today. This thread turns into atoms. Okay, eventually, and this is how we construct the atom. Okay, for those of you who are not familiar. Okay, we have that the two threads, they fork out at the boundary of the atom. Okay, one thread goes straight, the other one goes around, and from there, it goes to other atoms and so on. So we have rope, atom, rope, atom, rope, atom, all across the universe. So if this is all that is out there, the single closed loop thread, there is no room for poor old God in this scheme. Okay, God cannot be inside or outside, or if God wants to exist, he's got to be part of the thread. Otherwise, he doesn't exist. And you know what people like St. Augustine have done, and St. Thomas, they put God outside of the universe. Okay, you got to put him beyond the reach of the human mind, because otherwise he would be God, right? You would know God, and then God would not be so powerful. No, you got to put him outside our reach, and that way you keep him so all powerful. Okay, and that's a problem, because all you're doing is just not wanting to be trashed at the debate. Okay, so what we do, we stop that nonsense. We say, look, there's a single thread. God wants to be part of our universe. He's got to be part of the thread. He's got to be made of atoms. He's got to be made of the thread. And if he's not made of the thread, he's not part of that loop, then God does not exist, because he's not even a promise. Okay, God is not around, so I don't know. There's no purpose for God in the rope model. Okay, let's get on with good old Tyson here. Okay, the other day we covered his bio. Okay, here it is. I put him as a caricature, because I think that's the appropriate way to present Neil Tyson, not a friend, not a brother or anything from Mike Tyson, the boxer. He claims to be an astrophysicist, a cosmologist, and I don't know what else, but he seems to know very little about all this, as we'll find out today. Okay, and the other day we talked about Katy Perry. She interviewed him, and she said, look, what is knowledge and all this? And so he started talking a little bit about knowledge. He says, knowledge is what's inside the circle, and as that knowledge grows, all we're doing is increasing what's outside of it, which is our ignorance. So as knowledge grows, it's like ignorance grows at a bigger pace. All we know is that we know less and less and less, okay? And here I think that Katie was smarter than him, and she's not an expert on all this, but she obviously knows a little more physics than Tyson here, And so here we have his sea of ignorance. Here we have good old Katie inside it, because I think she knows a little more. She's not a very knowledgeable person, but her tiny knowledge surpassed Tyson's sea of ignorance. Okay, that's the way I saw the debate, or you can say a debate, the interview. Okay, so I think she did a better job than he did. And why? Well, because Tyson is simply a guy who memorized a lot of stuff that he just absorbed in college. And what's happening in the last 100 years is, one guy from one generation simply memorizes what the guy from the previous generation taught him. And that's what they've been doing with both general relativity and quantum mechanics. And so today all we have is yes men. And the system is wrong. It's not that there's a conspiracy, but the system leads to that. If you go and study physics today at any university, okay, well, what do you got to do? Well, you got to take the test. You got to listen to the professor, right, the instructor, and you better, mimic his words. You better say the same thing he says, or you don't graduate. And you got to go into some other career, maybe be a lawyer, a doctor or whatever, because you won't cut it in physics. And so the only way you're going to stay in physics is if you repeat the same words and think in the same way. Then your instructor, your professor, the school, whoever, your friends, they give you a recommendation to get a job as a professor or working at a think tank or somewhere, or maybe at CERN or SLAC or LIGO or NASA, So you get a good job, you get a good position, you get a good salary, okay? And the history repeats itself now for the next generation. New generation comes in, they learn the same nonsense by rote. They repeat it because they have to fall in line, otherwise they don't graduate. And this has been happening from generation to generation. And so today we have all these people just talking about nonsense. They just repeat, and they say, oh, it's been proven, And what do they talk about? Big Bang, black hole, dark matter, Higgs. They smash particles that they can't see, virtual particles that pop in from the void. A particle can be at two places at once, and on and on and on, You can travel through time. You can go see your grandfather, kill him, or go see your grandson and kill him as well. They talk about nonsense. And that's essentially what happened here. We have Neil Tyson. He interviews his ex-professor, or he wasn't his professor, but he was the guy who brought him to Columbia University. And this fellow also was, I guess, the guy who he had to defend his thesis against for his doctor's thesis. And his name is David Helfand. Okay, and this is what these people say. Tyson, right, in this interview that he had with David Helfand, said, we live in an age of magic. In this day and age, if an old scientist tells you that something is impossible, he's probably wrong. Technology is indistinguishable from magic. And yes, in the sense that whatever Hollywood puts out there, Matrix, whatever, they say it's not science fiction anymore. That's science. It's a documentary that you're watching, not an entertainment show or whatever, And this is a problem. This is a serious problem because people can't distinguish reality from this world of abstractions that they've created in Hollywood. And so, in a sense, he's right? But on the same token, you've got a problem here because, again, people can't tell the difference between reality and an abstraction. Okay, this is where the problem is, and neither can these two guys, as you'll see in a second. Okay, these folks were lost complete. Yeah, it's magic, but see, we also have to distinguish what I said the other day. You have to distinguish between a guy like Jules Verne, who said, we're going to go to the moon. He said that at the end of the 19th century. Okay, and we're going to float around with balloons, etc. Around the world in 80 days in his balloon. And I don't know if anyone has done that one, but we have gone to the moon, and so we have a problem because that was within the realm of possibilities. Okay, it was within the realm of possibility. But to say that you're going to go through the fourth dimension using, what was it he said the other day? Michio Kaku, that you're going to have this mass effect where you interface with space-time and travel from one end of the universe to the other through space-time. You know, now that's stretching it a little bit. In fact, more than a little bit. That's surrealistic. That's never going to happen. And so for them to say that, you know, anyone who says something is impossible is not in tune with physics or with science. No, he's not in tune with Hollywood. That's different. Being in tune with Hollywood is not the same thing as being in tune with reality or with genuine physics. Okay. Okay. See if I can get myself in here again. Yeah. Okay. And so where does he go from here? Well, he says, see, in fact, here's one of the issues. The gravity probe B is a good example for this. When you want to assert a new scientific truth, you cannot link it to a single research result. That's what they were debating. They say you can't just use a single point. But see, you have things like the gravity probe B, which was run only once, and it was run by NASA. Okay. And the question is, can you do the gravity probe B and send it out into outer space, these perfectly made gyroscopes, and measure what they allegedly measure, which is that the Earth drags space around itself, you know, like a whirlwind, like if you're dragging water around yourself, like in your toilet? Can you do that? In fact, see if I can find it here. This is Brian Greene, who illustrates this in one of his shows. It was The Fabric of the Universe. Is they sent these gyroscopes, and with that they measured, or they detected, or they proved, any word that you want to use there, that the Earth drags space around itself. Okay? And so can anyone reproduce this experiment? You know, can you do this? I mean, if it's a single shot, like they're saying, you know, that doesn't count. Well, we only have a single shot for gravity probe B. Nobody else can run that experiment. And what are we supposed to do? Take NASA's word for it, especially when good old Brian Greene says that the gyroscopes were wobbling. And, you know, they corrected that before they put out their report. It took them 2 years to correct that. And so, I mean, it was supposed to measure the wobbling, essentially, and they said, well, there was a wobbling, but we fixed that. And these guys are, you know, the wolves that are guarding the sheep. And so, I don't know. He says that's not science. Let's put that back up here. You know, he says, when you want to assert a new scientific truth, you cannot link it to a single research result. And they did. They did that with gravity probe B. They did that with many things. LIGO, gravity waves, single result. The black hole they took a picture of, single result, and so on. You know, so they have all these single research things where a guy gets his name in the lights momentarily, gets in the news, maybe wins a prize. And then they go out there and they just say, oh, we proved it. See, so-and-so proved this and so proved that. And it's a single incident. A single paper or whatever. So yeah, we got a problem. If that's not science, then none of that is science, because we have no second opinion. Okay, not in these things that they're doing out there in space. Okay, here's another thing that they brought up, which I thought was very interesting. It's got to do with tenure, how the scientific world really works. This is important for you to keep in mind, because this is how the politics of science is done. There's this pressure to get grants, okay, money, and so you have to produce positive results to your next. In order to get your next grant, you have to get grants because you have to get tenure, and you have to get tenure by publishing in prestigious journals. Okay, so that's how this works. Okay, and one guy made a comment: tenure is academic gangsterism. Yeah. There's bias from funding resources, from funding sources, okay? We are less susceptible as astrophysicists. Why? Because nobody's funding them. He claims this, okay? Pfizer doesn't care what a black hole space-time continuum is doing, okay, because they do pharmaceuticals, right? The scientists are participants in the misinformation when you are biased by your funding sources. In other words, you know, if you're a doctor and they're trying to push some kind of drug into the market, well, you know, they're going to make sure that if you're a researcher within the medical field, that you vouch for their product. But they're saying that that doesn't happen in astronomy. Why? Or in astrophysics. Why? Because in our field, astrophysics, it's really easy. Okay, there's the record of the sky. You can't mess with it. We have these huge repositories where you take data. It goes into that repository, and anybody else can go in that repository. It's very hard to manipulate raw data. Data is like gold to us. That's an emergent fact about our field. Your raw data, when it's publicly funded, it goes public right away. In other words, you can't mess around with all this data. That's what he's saying. Well, a lot of it is not data, it's interpretation. I mean, what is a black hole? What data is there for a black hole? What data is there for dark matter? What data is for a Big Bang? All these are inferences. You know, they surmise that this is what's happening. But that's their physical interpretation based on this notion of mass, because they think everything out there is governed by mass. And so they come up with these things and they say, what else can it be? It's got to be black hole. It's got to be a dark matter. There had to be a Big Bang. Okay, so this is how they present it to you. But then the issue is also that, these people receive funds from the government, because NASA may not, it might be partially privately funded. I don't know about that. It could be. But for sure they're receiving money from the government, which is your tax dollars. Okay, so all these European space agency, the Russians, the Japanese, the Chinese, all these people receive government money. And the issue is that they don't have to produce anything. Okay, the theoretical physicists within those groups, they don't have to produce anything. Okay, it's not like me in engineering. I couldn't go to my boss, my engineering manager, and say, "Look, I want to run a test, an experiment. It's going to cost $10,000. I need some wafers. I need some operators to run it. La la la." And he said, "What are you trying to show, Bill? Show me your design of experiment, your DOE." DOE before E. Design of experiment before experiment. Okay? And what experiment could they do for gravity probe B, Earth dragging space around itself? Are they going to give me a picture of space? Because that's where they would have to start. They would have to show that space is a physical object. Now they took it for granted and said, well, Einstein proved that. So we're just at the next step. We're going to drag it. We're going to prove that a gyroscope, is going to detect the dragging of space. That's the way they did it. Okay? And, okay, so they go into dark matter. They go into a little discussion on dark matter, which is an interesting subject because they needed that. They needed to explain certain things out there, especially what is known as the galaxy rotation problem. Okay, the fact that stars on the outside go faster than the ones on the inside. And they couldn't explain that except by sprinkling mass on the outskirts of a galaxy. Okay, so Tyson says there's crazy things that we scientists are saying are true, and then we chastise someone for thinking that crystals, rubbing them together, will heal them, which sounds way more possible than the existence of dark matter. It's basically hard to believe science truths and false believable truths. Okay. And Helfand replies, he says, I try to avoid the word truth when it comes to science. Love that. That's true. Mathematicians can prove things true. Okay. Scientists make ever better approximations to the way the universe works. I like that because he's saying that mathematicians aren't scientists. And they're all mathematicians, so none of them are scientists. So I love the corollary on that one. Okay. Dark matter is a current approximation. No, that's a lie. Dark matter is proven truth now. So he's lying there when he says, he tells the public this, but that's not the way they treat it. When you go out there and say, look, dark matter has not been proven, they say, yeah, it's done deal. We're now at the next step trying to find it. They're not questioning dark matter anymore. And so for him to say that it's just the current approximation is nonsense. Okay? It is detectable. It is detectable in that we can detect its gravitational influence in the things that move around in it. So they're not seeing, or they're not proving, or the existence of dark matter. What they're doing is saying, look, we saw this star doing this little thing here. It's moving faster than one on the inside. What else can it be? It's got to be dark matter. What is dark matter? Dark weight, kilograms, a bunch of weight that we put in there to make the equation come out right. That's what they're doing, okay? And they call this stepping stone to knowledge. We just can't see it with our eyes, but seeing with our eyes is not the only way that you can detect something. Yeah, because what they're doing, they're inferring, okay, these things, and they call these inferences, they call them proofs, or temporary facts, or knowledge, or whatever word that they use to shove it down your throat. That's what they're doing, okay? Okay, so here's the issue with relativity's dark matter. What is that? Well, they had this problem where the stars on the outside were moving faster than the ones on the inside. And that's counterintuitive because Pluto goes much, much slower than Mercury. And that's not what stars do. Stars on the way far outside of the galaxy move faster. And, that's what they measure. Now they can't explain it. And the way they explain it is by sprinkling what I call dark kilograms. Here's this is what they do. They sprinkle dark kilograms around the graph, and they say, oh, with this we can explain why the stars on the outside go faster. We just needed more weight out there. That's the way they explained it. Okay, have they proven the existence of dark matter? Okay. Well, let's accept their dark kilograms. I'll accept them, okay? Let's concede for the sake of argument. Here it is, okay? And so the question is, here you have a black hole, and you have a star going around a black hole. And you say, well, how do you produce that effect? Well, the way we do it is we say that this black hole has a lot of mass, okay? So it's got mass. And so the star just goes around it because there's mass. Okay, just tell me now the mechanism. Tell me how mass physically comes in contact with that star and forces it to go around. That's what we need to understand. We need to understand the mechanism. And the same issue is with dark matter. Here we have these dark fishnets, as I call them. So each one of those fishnets is dark matter. And here you have several stars. They look like our sun, okay? And they're all very far away from the center of the galaxy, which obviously contains a black hole, according to these people. So we have a big mass in the center of the galaxy, and we have these outer masses, invisible masses, which are weighing the space-time canvas or fishnet downwards. And here this is surrealistic already, because we have these dark matter particles. They're not pushing outwards radially from the center of the galaxy. They're pushing downwards. That they would have to push downwards in order for the stars to feel the effect to make them go faster. And then what this would do is compel these stars to go around in circles or fall into this gravity well. So we got all kinds of surrealism here that is unexplainable from a physical interpretation point of view. They have no explanation for this, okay? And so how do we do it on the rope model? Well, I showed that the other day. Here's just a summary, and that's all stars are interconnected, physically interconnected. That explains why the stars on the outside do not travel out of the solar system, and at least it tells you why they travel at least as fast as the ones on the inside, because what you have is, you have the buggy on the outside of a carousel going as fast as the horsey on the inside. That's essentially it. We're done. It's very simple. It's baby stuff. It's kindergarten stuff. A galaxy cannot be as complicated as they made it to be. It's got nothing to do with mass. It's got to do with the fact that all these stars and atoms are interconnected, so the whole thing rotates as a single platform. And now we can explain why the stars on the outside don't fly out, why they stay faithful to the galaxy, which is one thing they cannot explain. And we don't have the surrealism of potholes in the wrong direction. They're downwards instead of outwards from the galaxy to make the graph come out right. So this is the issue. The issue is you got to come up with a physical mechanism. And by Tyson and his buddy there to say, well, we infer it by watching the visible stuff. Well, they inferred wrong. And for that inference to turn into a fact, into proof and evidence and verification, that's a long step, because they haven't even explained how mass physically, mechanically compels a star to do anything. You can't just put a concept, a mathematical concept, and say, oh, there's mass there. Okay, so there's mass. And? So there's dark matter, dark particles, whatever you want to go, dark kilograms. How do they interface with the star, with the skin of the star? How do they do that? To say that the equations, it comes out right? Yeah, because if you put whatever garbage you want into an equation, it'll come out right. It'll mimic what's out there. That doesn't mean that you've proven the existence of dark matter, and you won't prove it until you come up with a mechanism. I need to see the connection between this so-called mass thingy and the star. And until you can show that, you have no case. Okay, that's it. Okay, so they go another step further, and they ask this fellow, how does he know about the existence of dark matter? Okay, it says, now dark matter, we have been going through various hypotheses. Okay, are they dead stars? Are they missing runaway planets? And we knock those off one at a time. There are some things we haven't knocked off yet. Are they little subatomic particles from some other part of the particle zoo that we aren't familiar with yet? And that's got to do with, the standard model. Right now, they're at CERN trying to figure out dark matter. So they're trying to collide particles to see if they can create dark matter in their basement there, And yeah, good luck with that. And they're going to find it for sure. Someone's going to crash something and say, oh, we found it. And he gets a no, and then they say, oh, by the way, there was another particle that came out. Now we're going to need more funds to find out what that particle is. We're going to call it the Peter or the Johnny particle. And now we got to find the Johnny particle and find out how much that weighs and give me more money, more funds. That's the way it's been working for the last 100 years. People are working hard, spending lots of money and effort to try to find them, the particles, right? People are leaning towards a family of particles that don't interact with ours. That's where most of the money is being spent, in that direction. So this is what your tax dollars are being spent on, because not only CERN, but others are trying to find this dark matter thingy, okay? And goes one more step here. And he says the following. He says, what we're describing fits the data available to us. It's an ongoing process. No one is saying definitely this is the deal. Yet they are. That's what they're saying, because no one can question dark matter. So there, it's a lie. It's a total lie what he's saying here. What we're saying is, in our best knowledge, this is where we are now. No, that's not what they're saying. They're saying that dark matter has been proven and nobody can argue about it. And there it says, no longer science reporting in the news a major weak point in this problem. Right. So that shows you that it's a done deal. Nobody's criticizing dark matter anymore. It's a done deal. Dark matter is here to stay forever, until the extinction of man, right? So, yeah. And then final question was about Big Bang, okay? And again, it shows you what all these astrophysicists, as they call themselves, cosmologists, this is what they do. Tyson asks, in your lectures, you say that the entire universe once fit inside a marble. He's referring to the Big Bang, okay? Why are we going to believe that at all? Yeah, good question. Why are we going to believe that, okay? Where's the believability there, okay? And Helfand answers, again, it's a model. That's what we do. We build models of the way things work. We have a model that makes predictions. So they're predicting the past. They're predicting that there was an explosion 14 billion years ago. Yeah, I would like for them to predict when I was born. What else can they predict for the past? Who was a grandfather? Can you predict that? I mean, anybody can predict the past. Try to predict the future. That would be a little more interesting. So these people talk about the word prediction, and they say, well, we can predict what happened billions of years ago, because this is what should have happened right after that. That's their reasoning. They call that a prediction. In other words, they put themselves at ground zero, okay, at Big Bang itself, the moment of the explosion or whatever. Some say it wasn't an explosion or whatever. Space expanding, right? So you're at the center of the storm, right? from there you make predictions, and you say, well, then first matter would assemble, would come out of that explosion. Then we go into stars and galaxies and so on down the line. We end up with the universe we have today. That's how they look at it, and they say, well, the prediction is that we end up with a universe we have today. So it's a foregone conclusion. They know how the universe is today, and they just work their way backwards. They reverse engineer it, and they say, well, you know, if we had a big bang and so on in the past, these are the steps that would lead to where we are today. That's how they figure out, you know, all these things. And they do a lot of math, a lot of equations. They say, we've proven it. So nobody can question Big Bang. No one can question dark matter, none of that stuff anymore. Okay? But I like this one best. Let's see if I can get it in here to do our closing argument here. Give me a second. And here it goes.
Will you be good enough to explain all this?
First of all, I would like to make one thing quite clear.
Yes.
I never explain anything.
Yeah, good old
Good enough to explain all this.
good old Tyson. He's really doing. He's not doing science. He's doing entertainment. And to call that science, what he does, or mix it with science, or insinuate to the public that he's doing science, that's false advertising. And that's where I come in and treat him like a clown, because he does a lot of clowning around, but in the end he doesn't come up with anything that's real, anything that you can understand. All he's doing is just repeating what people out there are saying, and from his guild, right? And yeah, so he doesn't explain anything. And that's one of the things that you can tell that he's a mathematician, because no mathematician can explain anything in a rational manner. I mean, they do explanations, but they're all ridiculous and surrealistic. That's not the same thing as saying, I'm going to explain a mechanism objectively so that you can understand it. Okay? Like, for example, you know, I pull on a rope and there's a pulley. The rope is tied around a pulley and pulls the box up. So I explained to you how the box came up, and I said, look, I tug on the rope that's connected around the pulley, okay, and the box goes up. And everybody understands it. So all you got to do is understand it, because you see every bit of everything that's involved in my explanation. That's not what these people do. They never come up with an explanation, a mechanism, okay? And so they use these fancy words, especially a bunch of concepts, and they end up, you know, first not explained, then they look like clowns. They do a lot of clowning around. I mean, if he says, look, he's more like Bozo the Clown, I have no problem with that, but don't tell me that he's a scientist. But see, the issue is that they brought him over because he's got this title of mathematical physicist. And so they say, hey, we need this guy because he's a good communicator. We're going to put him in there, and we're going to tell the public whatever nonsense we want to tell them from the mathematical physics world. And if you call that science, well, then we have a problem, because they're packaging science you know, in the guise of this comic, in this comedy that they're doing, this circus, this clown, okay? And so one of the issues that came up is the issue of nothing. What is nothing? And here's good old Tyson, and he says the following. He says, in fact, he says, Tyson explains nothing. I agree with that. He explains nothing. You open a box, it is empty. He's going to try to explain to you what nothing is. Listen to this. You open a box, it is empty. You say there's nothing in the box, okay? But there are 10 to the 25th molecules per meter cube of air in there. Then he goes through an analysis. Look, he says, atmosphere 10 to the 25 molecules per meter cube. Okay, lab vacuum, you can get that down to 10 to the 10th molecules per meter cube if you have a good enough vacuum. Interplanetary vacuum between planets out here in the solar system, 10 to the 7th molecules per meter cube. Okay, interstellar vacuum comes down to 500,000 molecules perhaps per meter cube. And when you talk about intergalactic vacuum, maybe you're talking about one particle every 10 meter cubes. In other words, hardly anything out there. Now he says, let's assume we remove all the particles. We remove even that last particle, nothing in there. Okay? And he says QM alleges that there are still virtual particles comprising the vacuum. So you removed all the matter particles. Now you have pure vacuum, pure nothingness. And he says nothingness is made out of virtual particles. That's what QM says. You remove the virtual particles, you still have the laws of physics. And when you remove the laws of physics, what you have is warped space. That was his reasoning, okay? Let's see if I can illustrate that, what he was saying. Okay, give me a second here. Okay, so here's a box, okay? It's got nothing in it. You remove the atoms, the virtual particles, time, laws, energy, everything. What you got is warped space. He says space is a thing. Okay, listen to that. Space is a thing. Space can bend according to Einstein and relativity. That's a thing. Yeah, if it can bend, it's a thing, no doubt about it. The fabric of space, okay, that's what it is. Space, no matter what's in it, will bend with or without virtual particles. It's still a thing. Well, yeah, if it can bend, it's a thing. The question is, what is this thing? Okay, can you draw it? Can you draw a 4D space-time? You have a region where you get rid of all particles, get rid of every laws that describe nature. Then there is not only not matter, there's not energy, there's no laws of physics, there is no time itself. Put that in your box, open it, and now you have my permission to say there's nothing in the box. You just contained it and turned nothing into a thing. What do you call it? Okay, so we have a problem because, yeah, he says he turned nothing into something, which is that something that's enclosed there. And we go back to square one where I started today with the guy and the ball. If you remove the outside covering of the ball and you have only space in there, well, the question is, does that space start floating outwards? Does it change its shape? And the question is, what surrounds that space? That's the issue. And so this is the issue. The issue is that, again, he doesn't explain anything. So yeah, I like to put good old Neil in the proper light. And here I'm going to do that. Offend who I may offend. This is Neil trying to explain, nothing. He says he's going to explain nothing, and I agree with him. He explained nothing, but this is the real Neil, okay? I think he's a clown. And if he's into entertainment, he should keep it there. He should not mix that with or insinuate to the public that he's a physicist. He's not a physicist. He's not a scientist. Scientist is a guy who explains a mechanism. This guy can't explain who his mother was. Okay. Anyways, that's the story for Neil today. I'm going to continue with this line of bashing some of these so-called celebrities that are popularizing mathematical physics, which has nothing to do with physics or with science. It's just nonsense physical interpretations that these people are deriving from their measurements, from their equations. Then they do an experiment, again, more measurement, more equations, and that's all they do. And it's the physical interpretations we're concerned about. Are they real or are they not? Are these just analogies like they say and don't pay attention to the analogy, or should we pay attention to the analogy? Because we're trying to figure out how this universe works. You would think that if they say, look, warp time is what prevents the Earth from flying out of the solar system. There's a wall of warp time coming in physical contact with the skin of the Earth, and that's why the Earth cannot fly out, because there's this wall there. I mean, this is what they're saying. They're saying there's a depression, right, caused by the sun, and the Earth just rolls around this depression, meaning there's a wall that prevents the Earth from flying out. And when you confront them, they say, well, it's just an analogy. You're not supposed to take it literally. Well, then please explain why the Earth doesn't fly out of the solar system. So we're back to square one. And we get this circular argument from all these people. And what they're doing now is they're putting all these celebrities like Brian Greene, Michio Kaku, and Neil Tyson, and so on. And these people are giving this information to people who are not very, to the public, with people who are not very much in, they're not in touch with physics, and they say, oh, okay, you're the physicist, you're the guy who knows, and this is what you found out. Yeah, he could have said angels for all we care, and people would believe him too, because so there's a mathematical equation for angels. Yeah. Oh, okay, so angels carry the Earth around the sun. Okay, you can say anything you want, because people are not into science anymore. They've lost touch with physics and science, and if they tune into programs like Neil Tyson's, StarTalk, they do so for entertainment. They're not going to get any information there about mechanisms of how this universe works, especially in cosmology, which supposedly is his line of work. Okay, with that, we'll see you next time, and we'll keep bashing some of these celebrities. But remember, it's not bashing, it's what we propose